My name is Jacob and welcome to Education. Today I'll be showing my morning routine. So every day I do typing tutor, and if you look on the bottom it shows you where to put your fingers, and you have to be very careful to put it in the right spot. And we'll show you a quick example. The faster you type, the funner it is. Every morning I practice typing for 15 minutes. And after I'm done with my typing tutor, I go to khanacademy.org to practice math and the other stuff. So in Khan Academy, you have 4th grade reading and vocabulary. You have arithmetic, computer programming, and grammar. You can also come over here to progress and look at your progress through the days. I really like Khan Academy, and I do this for an hour every morning. We're done with my morning routine. We're going to learn electronics and programming to make a speedometer for my bicycle.
Alright, so in this next video, what we're going to be doing is we're working on a speedometer for Jacob's bicycle. And so we have a wheel. This is not the wheel off of Jacob's bicycle, but we're going to use it for our experimentation first. And so what we're going to do is we're going to first have to find the circumference of this tire. Do you know what the circumference is of something? It has something to do with pi, but we're going to figure that out in a minute. But the circumference of the tire is, if you were to put a string and hold it on the outside of that tire and go all the way around that tire on the outside, that's the circumference of the circle. It's the circumference of the tire, the wheel, whatever it is that you're working with. So the circumference is the length if you were to go all the way around that tire. So how do you think would be a good way for us to figure that out so that we can get a pretty accurate measurement? Because holding a string on there is going to be a little tough. So what we're going to do is we're going to put a piece of tape around the tire, and then we'll lay that tire out and put a piece of tape on the floor, and then we're going to measure. We're going to roll that tire until that piece of string or the piece of tape hits the floor again, and then we'll measure in between those two lines. So that's what we're going to be doing in this video, because before you can tell how fast you're going, you have to know the circumference of the tires that you're rolling on. All right, so the first thing that Jacob's going to do is he's got to put a piece of tape or some mark on the tire itself so that we can keep up with where one revolution of the tire ends up on the floor when we actually get down to it. So he's just taking a piece of thin tape, and the thinner the tape the better, because it gives you a more exact spot on the floor to mark. So now we're going to actually lay this out on the floor and see how we're going to determine what the circumference of this tire is. Okay, so the first thing that Jacob's going to do is he's going to put a mark on the floor that we're going to actually use to line the tire up with. So it doesn't matter where the mark is, we just want to make sure we have enough room to roll the tire in just a second. So all he's done at this point is he's put a mark down here on the floor, and you can see the mark right there. So there's his first mark that we're going to put on the floor. So the first thing Jacob has done, we've got the line on the floor, and now we have lined the tape up with that line. So we've got the tire lined up right in the middle of that piece of tape. So no matter how big the tape is that you're using, you want to make sure you put it right in the middle, and that's where we're going to mark it when we get around to the other side of the roll. So now Jacob's going to roll the tire straight ahead, and we're going to roll it until that piece of tape hits the floor again. There's the tape coming around. And so now he has the tape down on the floor again, and now we're going to make another mark on the floor So we're making another mark on the floor where that tape hit. And so now we're going to come back over here, and Jacob's going to roll the tire one more time just to check and make sure that mark is in the right spot. All right, so now he's going to roll one more time. There comes the tape, and then it should hit his mark. Did it hit it? All right, so the next thing that Jacob's going to do, and I'm going to get down here and help him, but the next thing he's going to do is he's going to stretch the tape from the first mark to the second mark, and that's going to give us the circumference of the tire as it rolled across the floor. Okay, so the tire that we just rolled out on the floor was exactly 81.5 inches according to the ruler. So we're going to take a look at the ruler real quick and see how you read a ruler. So as you can see, the measurement right now is 81.5. So we're going to go back in the office now, and we're going to actually see what this means as far as the circumference of the circle, and see if there's some other way that we could have used to figure out what this circumference was going to be. So before we go inside, we want to get Jacob to measure the diameter. And what is the diameter? You know what the diameter is? The diameter is from one side to the other. So diameter goes from one side, the outside of here, to the outside of over here. That is the diameter. Now, what is the radius of this circle? The radius is half of that. So if you wanted the radius, you would just go from the center over to the edge. So from there to there gives you the radius. So here's the radius of the circle. The diameter goes all the way from one side to the other. So diameter, radius. And so we need a measurement, because we're going to look and see if there's another way we could have figured this out without walking out here in the shop and doing all this extra work. So we're going to measure right now the diameter, because we can always split that in half to come up with the radius. But we're going to measure from the outside edge of the tire here, and we're going to come over here, and Jacob's going to tell us what the reading is on that side. So it's 27 inches from the outside over here to the outside over here. So half of that would give you the center. So what does the center actually look like, Jacob, right now? Thirteen and a half. So 13.5 to the center and 27 over to the other side. And the nice thing is that 13.5 ends up being half of 27 inches. So you did good. So the first thing that we're going to do is we're going to have Jacob draw our bicycle wheel. So he's going to start off putting a point in the center of the tire, and then he's going to try to draw as good of a circle as he can around that circle. And now, Jacob, I want you to mark off what the diameter of that circle looks like. Okay, so the diameter goes all the way through the center of the circle, and from outside edge to outside edge. Now show me the radius of that particular tire or circle. So the radius is only half of the circle diameter. So the only difference between a diameter and a radius is that one is half of the other. So if somebody were to say that that's a 2-inch radius, well, all you got to do is multiply that times 2, so it's a 4-inch diameter. Same thing, if we had a 4-inch radius, a 4-inch diameter, you divide it by 2 and you got the radius. So either one of those numbers that you get, you can still work any kind of equation that you want to work. Okay, we have to make one small correction with our calculation. So when Jacob measured the wheel, we put a line on here, and we put a piece of tape on the tire, and then we rolled that tire over, and we measured the distance that it rolled when that piece of tape went all the way around the wheel and came back around to touch the floor again. And that measurement was correct. However, the tire that we're measuring, the tire is a little flat. And so what that means is that while the thing is sitting on the floor, it's compressed down here on the bottom. It's pushing down on it, and it's flat. But up at the top, it's pushed up because the whole tire is not sitting on the rim. And all that means is that when we measured the radius or the diameter of the tire, we actually measured that a little bit off. So instead of it being 26.5 inches, it's actually 26 inches even. So the circumference or the radius of this is actually 13 inches instead of the 26. So we're going to get Jacob back over here to explain exactly what we're doing here, and then we're going to talk about a little bit of math involved and how we could have done this a little bit differently. So we just came in from outside, rolling the tire around and figuring out exactly what we think the circumference of the circle is. So now we're going to take a look at an equation that somebody figured out a long time ago about circles, and it's a pretty cool thing. And so one of the things that we know is we know that if we take the circumference of this circle, so we've measured it on the floor and we got exactly what we think it is, or we're pretty close. We're not going to be exact because we're working with tape and markers on the floor and a flat tire, but we got pretty close. And so we have an 81.5, 81.7, somewhere around there. I went and we remeasured it after we stopped the camera, and we got like 81.825. So we've got a circumference that we think we have, and we know that two of the radiuses, so radius goes here, radius goes here. If you add 2r, you get the diameter. And so we know that there is an equation that is out there, and it's an algebraic equation, and this equation says that the circumference, which is what we actually wanted to begin with, is equal to 2 pi r. Well, what is pi? Well, another way to write this equation, and we're going to be learning exactly how we work these algebraic equations, but another way to write this is to say that pi equals the circumference divided by 2r, or d, because d is the diameter, which is 2 times r. So if we were to do the math on this equation here with the numbers that we got, which is 81.825 divided by 13, which was our radius, you end up with a number that is actually 3.14. Now, pi is a symbol that we use to represent the number 3.14. So instead of having to tell everybody 3.14, 3.14, because pi is actually used all over mathematics. It's a very, very important number. And so instead of having to remember this number all the time, we instead remember this symbol and we call it pi. And that allows us to very quickly say what we mean. We mean 3.14 pi. And so now what we're going to do is we're going to take a look at what happens when we rewrite this equation and we say that the circumference, actually we already have it right here, the circumference equals 2 pi r. So if we were to say that c equals 2 pi, which we know is 3.14, times the radius, which is 13, and we multiply that out, you're going to get a number that looks like 81.825, or pretty close. And so what that means is that we didn't have to go outside and measure the tire and put tape on it and measure the floor and do all of the other stuff that we did downstairs or out in the hangar with the tire and the wheel. We could have just measured from the center of the wheel down to the tire and come up with our 13, multiply that times pi, or 2 pi, and we would have had the number that we were looking at. So it's just a quicker way to figure out what that number is without having to go through all of the taping and measuring and everything that goes along with it. So one of the things that we got to do in order to write this program for the speedometer is that we've got to understand how this formula, how this equation is going to work out. Because we know a few things and we need to kind of expand on them a little bit so we understand what we're going to try to do. So right now we know that if we roll this tire, and Jacob's bicycle tire is going to be a different diameter, so we're going to have to take that into account when it comes up. But we know that if we roll this particular tire, that it went 81.825 inches. We also know that there are 5,280 feet in a mile. Now notice that I'm using inches here and feet here. So feet is designated by a single tick that goes up here at the top of the number. Inches are 2 ticks. So anytime you see a number and somebody has written 2 ticks on the end of it, you know that's in inches. And if it's got 1 tick, it's in feet. The problem though is in any mathematics, when you're trying to work out a formula or an equation, you always have to make sure you're using the same unit of measure, otherwise it's not going to come out correctly. So we either have to convert this into inches or this into feet, and we're going to choose to convert this into feet. So what I'm going to do here real quick is we're going to take 81.825, and we know that there are 12 inches in 1 foot. So we're going to divide that by 12, and that is going to give us, hit the wrong thing, 81.825 divided by 12. That's going to give us 6.819 feet. So right now we're going to get rid of this number because we're no longer interested in the inches. We're only going to be working with the feet. So I'm going to write that over here, 6.819 feet. So in 1 revolution, we move across the ground 6.819 feet. So now what we need to know is we need to know how many times is that wheel going to turn over to cover 5,280 feet. So now what we're going to do is we're going to go 5,280 feet divided by 6.819, and that's going to give us 774 revolutions in 1 mile. So it's going to take 774 times that wheel is going to go over in order to figure out that we've gone 1 mile. So our little speedometer is going to be clicking off every time the wheel goes across. It's going to flip a switch and it's going to count. So what we're going to have to do in our application when we write it is every 60 seconds we have to keep up with how many times that tire turned over in a 60-second period of time. So the last 60 seconds that we were measuring this, we got, let's say, 300 times the wheel has turned over in the last 60 seconds. So now what we need to know is how far did we go? How much of a mile did we cover if we only turned 300 revolutions? So if we took 300 and divided that by how many revolutions we go in a full mile, this calculator is a little weird, 774. So that means that if we turn 300 revolutions in 60 seconds, then we went 0.38 miles. So we didn't go quite half of a mile, which you can tell 774 divided by 2, this is smaller than that. And we didn't cover 0.5. So we're less than half of a mile that we covered in that 300. And so what we're going to do now is we're going to multiply that number times 60, because we looked at 60 seconds and there are 60 minutes in an hour. And so we want to know how fast we're going per hour, because vehicles and airplanes and boats, they all measure in miles per hour. So we're going to take that number and we're going to multiply it times 60, and that means that we are going 23 miles per hour. So for the most part, that is the equation that we've got to use, and we're going to be writing an application in Python, hopefully, that is going to take all of this information into account and come up with how many miles per hour, and we can take how many miles per hour and add in the distance that we traveled, and we can tell how far we went and how many miles per hour we went, and we may even be able to come up with some other ideas of things that we might want to track, and we'll take those into account as we go along with our program. But right now, this is the main math that we're going to be doing. And again, don't forget that anytime you want to do something like this, that you're going to be using the circumference equals 2 pi r to come up with the distance that you're traveling for every revolution.